Good morning, physics fans. How we doing this fine, sunny Thursday morning? Beautiful sunny day. It's supposed to be really, really nice out there. So hopefully you get a chance to go out there and enjoy some of the nice weather. I hope all is going well with your family. I hope everything's going well in your household and yourself. Once again, I suggest find some time to FaceTime somebody and have some conversation with somebody outside of just your general family. Rather than texting, rather than Instagram, rather than just sitting there watching TikToks all the time. Now, sit down and talk to somebody, and that will be a good diversion to the day and the events that are going on. I hope you're continuing with your social distancing. Please continue to be mindful and do our part in regards to it. I'm going to take off from what we did yesterday a little bit in regards to the buoyant force, because the response is back. It's sort of like an exit ticket for me. If you remember the old exit tickets, gives me an idea of what you comprehend and what you didn't comprehend. So we'll start off with just some ideas with regards to this, and this is all we will do for today. Well, the first off is, if I have a scale here and I have a 100-gram mass. If I put the 100-gram mass on my scale, now my scale is not going to be perfect, but it reads close to about 100 grams. Now, if I would take and submerge this mass, I'll back it up a little bit, in some water, and we watch what happens to the weight of, or the mass of this object. Okay, we go from 100 grams to about 95 grams, or about 90 grams. Okay, so we've gone from 100 grams, which is out of the water, to 90 grams, which is in the water. Okay, so obviously the weight of this, or the mass of this, is not going to be the same, along with the weight of this object is not going to be the same. Okay, and that's what we talked about yesterday, was the apparent weight. It's the weight of the object in the submerged fluid. Okay, when we submerge something, you don't weigh as much. Okay, the object doesn't weigh as much. Well, why don't you weigh as much? Well, that's the idea that we have with respect to the buoyant force. Okay, the buoyant force is the net upward force on the object, okay, from the water. So if we take a look at what we worked on yesterday, we have two forces from the water, one going up and one going down. And when we subtracted these, we had a net upward force. Okay, this net upward force is the buoyant force. So if I'm taking a look, if I have a net upward force for the water, which force would be greater? If my net force is going upwards, which one would be greater, which one would be smaller? Okay, that goes to one of the questions that was in the book, or in my assessment at the end of the notes. I have two forces here. Okay, I have force 1 and force 2. Okay, which one would be greater if I have a net upward force? Okay. The other thing that we did not take a look at yesterday, but I gave you that question just to see if you can figure out with respect to the side forces, because we also have side forces coming in here. We have two side forces that are coming in. Okay, two side forces that are going to push inwards. Once again, it's always going to act on the object. Well, if these are at the same height, is there going to be a difference in the forces? Okay, there should be no difference in the forces wherever your height is. Well, if my height comes down to here and I look at the force here, there's a force coming in from this direction. Okay, at those heights, it's going to be the same height. It's going to be the same force. And if I take a look at my arrows here, I'm always trying to compress and compress and push in. Once again, when you go and you sit at the bottom of a pool, you feel the pressure of the water on your head all over the place. It's pushing in. So I'm pushing in here, I'm pushing in here. Okay, your head's not flying one way or another in regards to the pressure. They are pressure here and pressure here. If the pressures are here, that means the forces are going to be here. Okay, so I have forces here, I have forces here, I have forces here. And once again, my head is not bobbing back and forth because of just sitting in a pool. Now, if I was sitting in a river or in the ocean, that's a little bit different because we have the currents, which is an unbalanced force in at that point. But if I take a look at my forces here, I'm pushing in here, I'm pushing in here, my head is staying in the same spot. This object is staying in the same spot, it is submerged. When I submerge this mass here, when I submerge this mass in this water, it's not moving either direction. It's just staying where it's at. So the forces on the sides are going to be the same. But they're going to go in opposite directions, because if they're both going in the same direction, this object, this mass would go flying that way. If once again I was sitting at the bottom of the pool, this force is going this way, and this force is going this way, it'd pull my head this way. But if they're going in equal but opposite directions, my head's going to stay in the same spot. So when I'm at the exact same height, I'm going to have equal but opposite forces there. Okay? Now, if we take a look at a block, okay, we're going to take a look at this block. The thing is we still have weight. If I looked at my example here at the beginning, I went from 100 grams down to 90 grams. Okay? 100 grams down to 90 grams. So if I would drop this weight, it would still go to the bottom. If I would drop this weight, it would still go to the bottom. Okay, I'm here, I don't want to drop it too far because I don't want to break the beaker. It's still going to go to the bottom. Okay, so I still have a force that's pushing it downward. I don't have a buoyant force that's going to shove the weight out of the water. When we jump in the pool, the buoyant force is not greater than the weight of our body. Because if the buoyant force is greater than the weight of our body, it would shoot us out of the water, okay, which would be sort of fun, but I don't think that's going to happen. Okay, it ain't going to happen with me. It's not going to happen with the mass here also. So you still have a downward attraction, which is the weight of the body. Okay, so you still, if I would sum the forces in the y direction, I have my buoyant force plus I have my weight, which is my force of gravity. So I still have my force of gravity, which is my weight. Well, what we have to do is we have to be able to calculate the buoyant force. Well, the buoyant force is calculated by the density of the fluid, gravity, and volume of the object. Remember, the volume of the object yesterday by Archimedes' principle is also the volume of the water that's displaced. Okay, so whatever we displace in our water, that's the volume of our object. Well, where we struggled a little bit yesterday in those extra questions is I have a block with a dimension 2 by 2 by 1. What we have to remember how to do is find the volume of this object. Well, if I have a block, this is a prism, it's a rectangular prism. And how we find the volume of the rectangular prism is length times width times height. So this is how we find the volume of this. So if I take a look at this block here, the volume of this block is going to be 2 times 2 times 1, or 4 cubic meters, which is sort of big, but I just try to keep it simple right now to keep it in meters. Eventually this will probably turn into centimeters, and we will have to do problems in centimeters, which means we have to convert them into meters at that point. So if I take a look at my buoyant force is equal to density of the fluid times gravity times the volume of the object. So if I look at my buoyant force, I have 997 kilograms per meter cubed, We have gravity, which is 9.81 meters per second squared. And we have the volume of this object, which is 4 meters. Now I know right now I'm going to have to change my volume or my mass of this object because the buoyant force is going to be greater than the mass of the object. So we'll make some adjustments up here. So if I calculate 997 times 9.81, let's see, we have 997 times 9.81 times 4. We come down to a buoyant force of 39122.3 newtons. Well, I'm going to have to adjust because my cubic meters here and my cubic meters here is making this rather large. So I'm going to have to adjust my mass up here. The mass of the object, let's see, we're going to go 20,000 kilograms. Let's make it 10,000. Let's make it 10,000 kilograms. So that's going to be the mass of the object. Here's my buoyant force, which is the net upward force. Okay, so my buoyant force is pushing the object upwards. My weight, which is my force of gravity, is still pulling the object downwards. It still wants the object to fall downwards. So we have 10,000 mass times 9.81. So we have 98,100 newtons. That is our force of gravity pulling it downwards. My buoyant force is 39,122 newtons. That's pushing it upwards. So our apparent weight is equal to, well, I have 98100 negative pushing downwards. We have our buoyant force, which is pushing upwards, 39,122.3 newtons. So my apparent weight minus 39 would be 58977.7 newtons. That would be our apparent weight. Once again, some of the problems within, I asked you afterwards, what you struggled with, and I think a lot of it is we have to determine this right here, the volume of the object. And how we find the volume of this object is length times width times height. So when we have the cube there, which is 2 by 2 by 2, okay, when we had the cube there, okay, we can find the volume by doing 2 by 2 times 2, or what I asked you about in that problem is the pressure, which is force divided by your surface area. So if I look at a cube, this is 2 by 2 by 2. If I look at one face here, if I look at one face, I look at the surface area of this one face. And how we find the area of a square is length times width, or side squared, which is a value of 2 squared, which is 4. we will continue to work on these types of problems. Adjusting a little bit how we are going to do things, because obviously you've heard that governor has pushed the extension of not being in school until May 1st. So we will continue to, I'll continue to assess you in this manner, along with giving you some problems, some homework problems to do. Now will be our assessments per lesson. And we'll continue that way, but it's important that you go through these types of problems here. That's also a way of being able to give me a little bit of assessment also. I will let you to go back and redo problems. So those are things that we'll be able to do, and we'll just adjust. Once again, we are resilient people. Okay, we are resilient people. This is our growth mindset in regards to how we learn and how we teach. Okay, we have to be open to new ideas. Okay, this is a new idea. Okay, this is something a little bit different, but it's something that you should be able to handle. I have full faith in my students and the students here that they will continue to work through the types of problems we have, and you will do a good job with it. You can handle this. There's nothing too much different outside of you not being able to socialize with your friends. You can still FaceTime your friends. You sit there and you FaceTime your friends, and you can work through problems. I strongly suggest that you do that. FaceTime, have your social interaction like you normally would do. I would continue to do that. So the only thing is different, that you're physically not sitting in these seats at this point. Okay, I will continue to post videos here. Okay, please continue to keep your social distancing. Let's make a difference here in regards to what we do and our actions that we do, and we'll get ourselves through this. And once again, we want to get ourselves back to some sort of normalcy again. Okay, so continue to practice your social distancing. This will be the last of my videos. There will be nothing tomorrow. This takes us into spring break. So this will be the last of this. I just want to give you a little bit of reinforcement of what we did yesterday and the problems and the questions that you had, and also a little bit better explanation of what happens with an object that's being submerged. Okay, so we will continue to work on this and continue to work through fluids, and once again, continue to work. You can do this. Okay, I have full faith in you. Okay, if I can adjust to technology, if the old man can adjust to technology here, okay, he has his iPhone now. He's figured out different things with the iPhone. I'm posting videos on YouTube now. I'm doing virtual learning. Okay, if I can adjust as an old man, okay, you'll be fine. You'll be fine. You'll be able to handle this, and we will get through this. Okay, I have full faith in that. Once again, you're going to have some nice weather coming up the rest of this week and this weekend. Go out and enjoy some nice weather, but please make sure you continue with your social distancing. Okay, also FaceTime some friends. Okay, talk to friends that way. Be able to have some social interaction now with respect to your friends. It's very, very important that you do that, because once again, we are a social society. It's how human beings are. We like to be social. Okay, so be social with your friends. Do it through FaceTiming. Take some time out and FaceTime somebody. Once again, if you can work through some problems, it's nothing different than sitting here in class. You can sit there and you can show each other the problems that you're doing and what your answer is. Okay, you can continue to work through that. If you have any questions, feel free to comment me. I posted a question yesterday. I tried to get something going in regards to, something a little bit different. What's your favorite video? What's your favorite movies you've been downloading? Okay, it's good to be able to do that. Have something a little bit different. Share some things. Once again, I found the Peanut Butter Falcon was pretty funny. Okay, it was pretty funny. You would appreciate it. And also Knives Out was pretty good too. Now, I will tell you though, there's a few harsh words in there. So the warning is there's some swear words in there. So if you don't want to deal with that, that's fine. You may not want to watch it at that point. But other than that, enjoy your spring break. Enjoy your time away from the educational aspect. When we come back, we will start dealing with things. You'll be receiving a letter from Mr. Black about what will be going forward, how we go forward. hopefully we'll keep our fingers crossed by May 1. We'll get back to some sort of normalcy. They say the next couple weeks are going to be probably the peak of what we have to deal with. So hopefully that's true, and we'll get ourselves back to some sort of normalcy. And it'll be a new normal for us. Other than that, adios. You folks have a good spring break. Enjoy your time away. Enjoy the nice weather. See ya.